Hi students, welcome back. Today we are going to look at another interesting problem called the ransom note. Let's head to the problem statement first. So the problem statement says we are given two strings, ransom note and magazine, and we have to return true if ransom note can be formed by using the letters from the magazine, and otherwise we have to return false, which means we have to check that a ransom note can be constructed by the letters in that magazine string. Okay, each letter in magazine can only be used once in ransom note. That means the frequency of characters also should match. So in a simple terms, ransom note should be a subset of all the digits in the magazine. Then we should return true, otherwise we should return false. So we are given two constraints as well. So the ransom note and magazine always have at least one character, and they are always lowercase English alphabets. Okay, that means they only have A to Z small characters. So if you closely look at this problem, this is very similar to the anagram problem we solved. In case of anagram, what we did, we were exactly matching the character frequencies are same in both the strings. Here, we have to check that ransom note is a subset of magazine, meaning that after the process, the count will not be 0, but it should be greater than 0. Okay, the logic as such is similar. Let's look at few examples first. So here we are given ransom note as A and magazine as B. Clearly A cannot be constructed with anything from B, which is why the answer is false. Whereas in the second example, ransom note is double A and magazine is AB. Magazine has A, but it only has one A, whereas ransom note has two A's, which is why this is also false. Okay, if you see this example, ransom note is 2A's and magazine has 2A's and a B. So clearly this is a subset of the strings of the alphabets here, which is why this is a true. Okay, so we will follow similar logic to whatever we have done in anagram. So first what we will do is we will form a character array map. Okay, we will calculate the frequency of all the letters in the magazine. So for that we need a map, and since we know that everything is small alphabets, there is nothing to uh, change or convert to lowercase or anything here. We just need a 26 character array. Okay, so what do we do? For int I equal to 0, I less than magazine dot length. Okay, I plus plus. So first we have to calculate the frequency of characters in the magazine and update the map with that. So in map, what do we do? Magazine dot get, not get, it's just caret I. So we are getting the character at I and subtracting A. Why are we subtracting A? Array indices are numbers. So this will make A's index as 0, B's index as 1 and so on. Okay. So at this point, we are incrementing the count of that character. So for example, if magazine has B in it, then map of 1 will be incremented. Okay. Now we have to follow similar logic for ransom note as well. Okay. So for ransom note, for int I equal to 0, map dot, what do we do here? Here we build the map. We have to compare the string with that. So we will decrement the count in this case. So in case of anagram, what we were doing was we were just checking if the count is 0. It should not be greater than 0 because anagrams, two strings should have exact frequency. Here, magazine can have more strings than ransom note. So we just have to check that it is not less than 0. It can be 0 or greater than 0. Okay. If it is less than 0, that means we have to return false. Okay. Otherwise, the default is true. Okay. So did you understand the logic here? So first we created a map of characters with magazine. So this map will have frequency of each character in magazine. Then we went through all the characters in ransom node and we decremented the count of it. At the end of it, if this can be found with all the characters in magazine, then the frequency should not go negative. It went negative, that means ransom node has a character greater than magazine. So we are just checking that. Anywhere if the count is negative, we are returning false. If none of the count is negative, then it is true. Okay, let's run this and see. Acha. Okay, let's submit this. Yeah. So this is accepted. So what is the time complexity of this? So if we consider the length of ransom note as so let's say ransom note size is n and magazine size is m. Then we have two loops. So this goes order of m times, this goes order of n times, and this goes order of 26, which is constant. So overall it goes order of m plus n times, where m and n are sizes of magazine and ransom note respectively. Now, okay, so it would be order of m plus n. What is the space complexity of this? Space complexity wise, we are creating a additional map of 26 characters, which is a static size. So it is still order of 1. Okay, instead of this static size of 26, if we create a hash map with ransom note and put all the characters in that, then it would be size of ransom note. But since we optimized it and consider only 26 alphabets, it is order of 1. Okay, hope you like this problem. This is very simple extension of the anagram problem. Do try it yourself. Leave a comment if you have any questions. Please like, share and subscribe. Happy coding.